Hey everyone, just kidding. Hello, welcome to Jedi Lesson 1B. We're going to be solving a problem relating to electric fields and Coulomb's law. I tried to draw a diagram of the problem as best as I could, but we're going to start off explaining the problem. So, our problem states that 2.2 microcoulomb point charge is placed with an external uniform electric field with a magnitude of 76,000 newtons per coulomb. We're asked to find the distance from the charge where the electric net field is zero. So here's my little sketch. Let me get my pointer. We drew a positive point charge and an external electric field going to the right. We also labeled, this is going to be our distance r. Maybe we should do that in red because I just feel like it. Our distance r, which is what we are trying to solve for. Before we start solving our actual problem, we need to define our variables. So what we are going to do is talk about a couple of things. Our variable q, actually I want to do these in fun colors. Our variable q is going to represent charge. Charge is, the property of matter, causes electric fields and forces. The SI unit for charge is a coulomb, which is abbreviated with a C. So, for this problem, we have Q is equal to 2.2 times 10 to the negative 6C. Awesome sauce. Our variable E is going to represent the electric field strength. I'm coming. Don't turn red. Okay. So the electric field's going to tell us the force experienced by this positive charge per unit charge. The SI unit that we're going to use for electric field is newtons per coulomb, which is represented using this beautiful NC. So we're going to get rid of that. We are given E, which is equal to, let's do this in black, 76,000 NC. We are lastly given our variable K. Wait, that looks like an uppercase. K, which is going to be equal to Coulomb's constant. K in this situation is equal to 8.99 times 10 to the 9th n m squared c squared. The variable, let's get a new color in here. The variable r is going to be equal to the distance from charge. This is going to be measured in meters. All right, so those are our variables. We are trying to solve for r. To find where the net electric field is zero, the electric field created by the point charge must have the same magnitude as the external electric field. If two of the points do actually have an equal magnitude and they point in opposite directions, they're going to help cancel each other out and produce a net electric field of 0. So we're going to use Coulomb's law. That special fun equation is going to be equal to E equals K. Actually, we're going to do this all in one color just because it's our equation. We're going to do it in green. E equals KQ divided by R squared. So we are going to not substitute, but solve for one of the variables. We're going to solve for R. So in order to solve for R, I'm going to start with that equation. Multiply both sides by R squared, which is going to give us ER squared equals KQ. Next, we're going to divide both sides by E, which is going to give us R squared is equal to KQ over E. Finally, just to get R, we have to take the whole square root of that problem. Now we're going to plug in our values. So when we plug in our values for this problem, we're going to do this up here. So we're going to plug in our values. So for K, we're going to have 8.99 times 10 to the 9th. For Q, we're going to have, sorry, these colors are not matching up to the ones I used previously, but it's okay. And for our E value, we are going to divide by 76,000. And finally, can't forget the most important part, we have to take the whole square root of that. So we can calculate the numerator first. So our numerator value is going to be equal to 19,778. And we're going to divide that by our denominator, which is 76,000. Take the square root of all that, can't forget that, which is going to give us our final answer that R is equal to 0.510 meters. So the distance from the charge where the net electric field is 0 is 0.510 meters. This answer makes sense because it's going to decrease, but yeah, thanks for watching my Jedi lesson. We get to plug in our beautiful answer right here. Oh, just delete like that. Love that. But yeah, that is our R value.